Before handing students independent practice, I work out 3 examples for them to demonstrate the 2 different methods that I've already shown them in the warm-up to simplify radicals. And then we'll talk about the 3rd example where there's a number on the outside of the radical to make sure they understand that anything outside the radical is multiplied, anything that stays inside the radical is multiplied. So in the first example, square root of 54, you could just think about, it's hard to think about what is the largest perfect square in that problem. So you can just start factoring using any 2 numbers that you know or any 2 factors that you know that multiply to make that. 9 times 6. And that 9 is actually the largest perfect square, so it comes out nicely where you can say, okay, square root of 9 is 3 because that's still underneath the radical, because that's still the same thing as square root of 6 times square root of 9. So square root of 9 is 3, and it comes on the outside. And then you can break down that square root of 6 to 2 times, continue breaking it down to 2 times 3, and there are no pairs, and you can see that you can't simplify it anymore. So the answer is actually 3 square root of 6. So that's using the perfect square method, and then or you can just continue factoring it into prime factorization. So I could have said, okay, square root of 54 is 9 times 6, and that's 3 times 3, and that's 2 times 3. And I can see that I have a pair of 3's using prime factorization. A 3 comes out. 2 and 3 don't have a pair with them to be a perfect square, so they're multiplied back together and they stay underneath, and it's 3 square root of 6. So either way, you get an equivalent answer no matter which method you use. 150, the 2 factors that come to mind is 15 times 10. And those are, neither one of those are perfect squares, so I'm going to continue breaking it down until I either see a perfect square or maybe just break it down into prime factorization. 3 times 5, 2 times 5. And I talk about, well, we didn't really run into any large factors that were perfect squares in that case. And so if you don't see any perfect squares, just keep factoring it till you get to prime numbers. These are all prime numbers. I see a pair of 5s, a 5 here and a 5 here. So that's actually square root of 25. A 5 comes out for the pair. And again, 3 times 2 is 6, and it stays underneath. So that's 5 square root of 6. And you can check that answer by thinking about 25 times 6 underneath the radical. Is that equal to 150? Yes, it is. And then 3 times square root of 12, the way you simplify that is you break down the 2 factors of, or any factors of 12, and I think of 3 and 4. 4 is the largest perfect square in that case. A 2 comes out for that perfect square, or you can continue breaking it down into prime factorization if you're not comfortable with pulling it out where the perfect square is. 3 is on the outside already. When that 2 comes outside from the square root of 4, it's multiplied times the 3. And the other 3 right there is left underneath the radical because it can't simplify, so it's 6 square root of 3. So you can use any method, the perfect square method, or pull out a perfect square anytime you see one, bring out one factor for that perfect square, and then make sure you multiply what's brought outside and multiply what's underneath.